Hello everybody. In this video we are going to be looking at the solutions for homework problems 1 through 5. So let's get started. Problem number 1. Four 240 ohm light bulbs are connected in series. What is the total resistance of the circuit? What is their resistance if they are connected in parallel? So I know that I have 4 resistors. Each resistor is 240 ohms. For resistors in series, I know the equivalent resistance is going to equal the algebraic sum of the individual resistors. Simply put, I just need to take all of my resistors and add them together. In this case, all the resistors are 240 ohms, so I just have to multiply that by 4, and I get an equivalent resistance of 960 ohms. To find the equivalent resistance in a parallel circuit, I know that the inverse of the equivalent resistance is equal to the sum of the inverses of the individual resistors. Now that's a little bit hard to put into the calculator, so I'm going to rewrite the equation using inverses instead of fractions. And when I do that, I'm going to have the equivalent resistance is going to equal the sum of the inverses of each resistors, and I need to take the inverse of that sum. So this inverse sign here is going to account for this inverse for the equivalent resistance. And this inverse sign is for resistor 1. This inverse sign is for resistor 2. This inverse sign is for resistor 3. And this inverse sign is for resistor 4. And when I plug it into the calculator, it's going to look like this. So I want to take, in parentheses, 240 ohms, and the inverse of that, plus 240 ohms, and the inverse of that, plus 240 ohms, the inverse of that, plus another 240 ohms, the inverse of that. I take that whole sum and then take the inverse one more time. And when I do that, I will get an equivalent resistance of 60 ohms. One thing to note is that in a series circuit, note that the equivalent resistance right here is going to be greater than the largest of my individual resistors. And in a parallel circuit, my equivalent resistance is going to be less than my smallest resistor. Problem 2. 3 45 ohm light bulbs and 3 75 ohm light bulbs are connected in series. What is the total resistance of the circuit, and what is the resistance if all 6 were wired in parallel? For the resistors in series, again, when it is a series circuit, I simply need to add up all of the resistors. So my equivalent resistance is going to be 3 times 45 ohms plus 3 times 75 ohms, and that is going to give me a total resistance of 360 ohms. For resistors in parallel, again, the inverse of the equivalent resistance is going to equal the sum of the inverses of the individual resistors. Again, there's 2 ways you can go about this. You can do it by adding fractions. I know you love fractions, and the one thing that you love about math that we haven't done a lot of yet this year is adding fractions. So that's one way to do it. And when we do that out, we'll end up with an equivalent resistance of 9.4 ohms. If you want to use your calculator, if you have a TI calculator and you want to write it out in a way that can be put into the calculator, you might want to do something more like this, and you should get the same value of 9.4 ohms. Again, I just want to point out that when the resistors are in series, my equivalent resistance here is greater than either of my individual resistors. And in parallel, my equivalent resistance is less than any of my individual resistors. Problem 3. Given only one 25 ohm and one 35 ohm resistor, list all possible values of resistance that can be obtained. So we have 2 resistors, First resistor is 25 ohms. The second resistor is 35 ohms. There's 4 possible combinations that we can have. We could have each resistor on its own. Then we could wire the 2 resistors in series, and we can wire the 2 resistors in parallel. For series, we simply need to add the 2 resistors together to find the equivalent resistance. So 25 ohms plus 35 ohms will equal 60 ohms, or if you're going to be a nudge about significant figures, it's 6.0 times 10 to the first ohms. For parallel, we're going to want to find the inverse of the equivalent resistance is going to equal the sum of the inverses of the individual resistors. And again, to do that in a calculator-friendly way, we will do that out and we will get a equivalent resistance of 15 ohms. So our 4 possible combinations for resistances are 25 ohms, 35 ohms, 60 ohms, and 15 ohms. Problem 4. Suppose that you have a 680 ohm, a 940 ohm, and a 1.2 kilo ohm, which is the same as 1200 ohms resistor. What is A, the maximum, and B, the minimum resistance you can obtain by combining these? So the maximum resistance is going to be found by wiring the resistors in series. And again, to do that in series, you find the equivalent resistance by just adding up the individual resistors. 680 ohms plus 940 ohms plus 1200 ohms is going to give me 2820 ohms, which would round to 2800 ohms into 2 significant figures. To find the minimum resistance by combining those 3 resistors, we have to wire them in parallel. So our formula for finding the equivalent resistance in parallel and the calculator-friendly version of that, if I plug my values into that version of it, I am going to get an equivalent resistance of 296 ohms, which would round to 3.0 times 10 to the second ohms to 2 significant figures. Problem 5. A 75 watt 110 volt bulb is connected in parallel with a 40 watt 110 volt bulb. What is the net resistance? Net resistance simply means the same as equivalent resistance. I guess I could have just said equivalent resistance and been less confusing, but you should know by now that's not my style. So we were given 2 light bulbs. The first one, 75 watts. The second one is 40 watts. They both have a voltage of 110 volts because they're wired in parallel. Remember, in a parallel circuit, the voltage is going to be the same across all components of the circuit or all branches of the circuit. Now, to find the equivalent resistance, I need to find the resistance of each of the light bulbs. And given what I know about Ohm's law and the Ohm's law diagram that Mr. Broderick showed you in the PowerPoint, I know that in order to find the resistance, when I'm given the power and the voltage, the resistance is going to equal the voltage squared divided by the power. So for the first resistor, the voltage squared divided by the power is going to be 110 volts squared divided by 75 watts. And that's going to give me 161.3 ohms. For the second light bulb, the resistance of that bulb is going to be 110 volts squared divided by 40 watts, and that will give me 302.5 ohms. Now I can find the equivalent resistance. So I plug my resistances for each of the light bulbs into the equation, 161.3 ohms and 302.5 ohms. That is going to give me an equivalent resistance of 105.2 ohms, which I need to round to 1 significant figure because of this value right here. So my equivalent resistance is going to be 100 ohms. All right, folks, that does it for problems 1 through 5. How many times have I said resistor or resistance in this video? If you get really bored in your social isolation, count them up and let me know. Until then, I'll see you back here for problems 6 through 10. Take care.